In the last section in Chapter 8, we're going to talk about circle transformations. So here we have a circle on the xy plane, and it has the equation x squared plus y squared equals 1. This is just kind of like a basic circle with radius equals 1. We'd sometimes refer to this as like the parent function. The center's at 0, 0 with the origin, and again, the radius is 1 here. But let's say I drew a circle up here, and I wanted to kind of relate that blue circle to the red circle. Doesn't look like the size changed at all, but it looks like I shifted it a couple units to the right and then up. This new circle has a center of 3, 3, and it still has a radius of 1. So I'll write its equation like this: x minus 3 squared plus y minus 3 squared equals 1. So we can see here that whenever we see numbers on the x's and y's, comparatively, that shows us if I shift that circle at all. Let's say I made another circle down here. It looks like I shifted it, and I made it bigger. This circle has a center of 5, negative 4, and a radius of 2, so its equation would look like this. So again, we could see that those numbers changing with the x's and y's indicate that a shift occurred, and also this radius value changing, or radius squared value changing, indicates that there was a dilation that occurred, or the size changed of that circle. Let's look at another example. Let's say I tell you that circle A has the equation x squared plus y squared equals 1, so like the blue one that we saw in the last picture there. And it's transformed to produce circle B, which is at x plus 4 squared plus y squared equals 25. Looking at the two equations, I want to describe the change that occurred. Easy way to do this is to write the center and radius of both circles and then make a comparison. So the center of circle A is at 0, 0, and the radius is at 1. The center of circle B is at negative 4, 0, and the radius is 5. So comparing the centers, it looks like I translated that circle to the left 4 units. Also, since the radius changed, it shows me that a dilation occurred, and how I find the scale factor, or how much I increase or decrease by. Remember that the scale factor is your new unit or measurement over your original one. So here we have 5 over 1, so it looks like I dilated that circle by a scale factor of 5. So it increased in size times 5. Another example that you might see in tomorrow's lesson, circle A has the equation x minus 4 squared plus y plus 1 squared equals 64. It is translated 6 units up and is dilated by a scale factor of 1/2 to create a new circle B. Using that information, I want to write an equation for circle B. So again, easiest way to do this, let's write the center and radius for circle A, apply the transformation, and then write the equation for circle B. So circle A has a center at 4, negative 1, and a radius of 8. If I go 6 units up, I'm going to add 6 to my y-coordinate. So my new center is at 4, 5. If I'm dilating by a scale factor of 1/2, I'm going to multiply the radius by 1/2, which is the same thing as dividing by 2. So my new radius is 4. Using that information, I'm going to create my new equation, which will be x minus 4 squared plus y minus 5 squared equals 16. And I'd be done.